let us solve this question. For each a element of real number defined by p of a polynomial in terms of a, and here instead of x we have the variable z. P of z is equal to z square plus 2 e raised to a minus e raised to a z plus e raised to a minus e raised to a. We have seen the question. Now, which of the following is true? We need to find. P of a has real root if a value is this one. P of a has only non-real roots, complex roots. Non-real complex root if all real number, for all real number a. We need to prove which is correct. First we can find the value of discriminant d. D will determine whether it has a real root or equal roots or a complex root. And there is one more thing. Complex root appears to be conjugate pair. Complex root will be always conjugate pair. Now we can find the value of discriminant d equal to b square minus 4ac. What is the value of b? B is the quotient of linear term x. We can apply quadratic formula. Instead of that, we can just check the value of d. D equal to b square minus 4a. What is the value of b? It is a quotient of z. It will be 2 e raised to a minus e raised to a the whole square, b square, minus 4 into what is the value of a? A is 1, quotient of x square is 1, and c is equal to e raised to a minus e raised to a. Now we can do one thing. We can take the square, which is equal to, or do one thing. What I am doing, I am taking the square value separately. 2 square and this one separate. Now I can take this 4 common. 2 square is 4. I have taken this 4 common. Now I can take e raised to a minus e raised to a again common. E raised to a minus e raised to a common. And here the 4 is taken out. This value, one of the value taken out, we have e raised to a minus e raised to a minus this will be 1. Now we need to find for what are the value. D value is greater than 0 for which all the value of a. We can check 2 or 3 conditions. First, this is the value of d. Now this is the value of d. See, a e raised to x is always positive, which means f of x equal to e raised to x is always positive. Exponent function is always positive. The graph of exponent function will be like this. Whatever the value you are putting, the y value is always positive, which means this is positive, this is positive. The d value, the sign of d value differs on this term. So if this term is negative, means there is complex root only. If this term is 0, means there is unique solution. If this term is positive, means there are 2 distinct real roots. Now we can find whether this quantity is positive or negative. E raised to a minus e raised to a minus 1, we need to find. It depends on this quantity. So if this quantity is negative, means only complex root. This quantity can be 0, means there can be a real root. If this quantity is always positive, means there is 2 distinct real root. That's the condition. So we don't need to check. We can check only the sign of this thing. This thing determines whether the discriminant is positive, negative, or 0. Now, if I put a value a negative number, suppose a is a negative number, what is the graph of e raised to x? E raised to x graph will be an increasing graph. E raised to x graph is an increasing graph. So if you put a negative value of a, e raised to minus a minus, this will be positive value because e raised to a is always positive, because so exponent function is always positive. So it will be a negative number. Negative of a positive number is negative number minus 1. What is e raised to this one? This will be 1 by e raised to some positive power minus 1. Since e is greater than 1, e raised to positive power, even the positive power is 0 itself, then it will be 1 minus 1, it will be 0. But we have put a negative value. See, it can't be negative, it can't be 0, it cannot be equal to 0. The magnitude of this quantity cannot be equal to 0, because if a is equal to 0, means this is non-zero number. So this will be a value less than 1, and this quantity will be always remains negative, because 1 by e value is always less than 1. 1 by e to the power some positive power. We have discussed it is only a positive power. 1 by e raised to a positive power is always less than 1, and this will be negative for all a less than 1. What happens if a is 0? If a is 0, means e raised to 0 minus e raised to 0 is 1 equal to minus 1, which will be e raised to minus 1 minus 1. See, if you put a equal to 0, e raised to 0 minus e raised to 0 minus 1. E raised to 0 is 1, and this 0 is gone, e raised to 0 is 1, it will be 1 by e minus 1. This will be always less than 0. So if a is equal to 0 means there is also complex root only. Now what about a greater than 0? If a is a number greater than 0 means a greater than 0 means e raised to a greater than 0. A value can be some positive value, positive, minus e raised to that positive number itself. Now exponent function, see, if suppose the value of e value is approximately 2.71, suppose e value is only 2, what is x? If x equal to 1, what is e raised to x? It will be 2 raised to 1. See, e raised to x is always greater than 1, greater than x. E raised to x is greater than x. See, if the value of x equal to 2, is e square equal to e raised to x equal to 2 square is 4, which means e raised to x is greater than x. E raised to x is greater than x. So if you put a value a, positive value, e raised to a minus e raised to a minus e raised to a is negative, because e raised to a is always greater than a, which means a smaller value subtracted by a positive value is being subtracted from a smaller value, so this will be negative. 1 by e raised to a positive power minus 1. This will be less than 1, and when you subtract 1 it will be always negative, which means if a greater than 0 also, this will be complex, which means P of a has only non-real complex root for all a element of real number.